Very good evening to all of you. I am Monika, working as Assistant Professor in EEE Department in Dronacharya College of Engineering, Gurgaon, Haryana. I am here to present a webinar on the topic Change Detection Techniques in Remote Sensing Satellite Images. So first of all, the introduction to remote sensing. In that, I will include what is the meaning of remote sensing and what are the various attributes of remote sensing. Basically, if we go to the definition, remote sensing is the acquisition of information about an object or phenomenon without making physical contact with the object. Means we are making a contact but not a physical contact with the things present over on the Earth's surface, and we are obtaining the information without actual contact with that. This is done by sensing and recording. Means the incident light that will be incident on the object and reflected back. So this is done by sensing and recording reflected or emitted light and energy. After that, processing, analyzing, and applying that information into a particular application. As you can see in the image, I have shown an image of remote sensed. In the remote sensing, basically, it is the satellite sensor for taking images from the space. Now, the principle of remote sensing. So what is the principle behind remote sensing? It is basically the remote sensing is basically the science of acquiring information on the Earth's surface, whatever the data is available on it, without actual contact of that particular object, and taking that data, analyzing it, processing it, and apply it on a particular application. So in that case, detection and discrimination of objects is necessary. Moreover, different objects return different amount of energy in different bands of electromagnetic spectrum incident upon it. Different objects will accept different amount of energy, and accordingly it will reflect the same. Why this happen? This is because of the property of the material. Whether it is structural, chemical, or physical. It not only depends on these characteristics, but also on the surface of the object, roughness, the angle of incidence, means at the angle at which the ray is incident on it, the intensity, and obviously the wavelength of radiant energy. So basically, remote sensing is not only a single system, it comprises of so many various systems in itself. That is why it is a multidisciplinary science. Because as you are taking the data, that is remotely sensed data, it is not only one system involved in it. Instead, various systems are involved in the remote sensing system. What are these different sectors? First is optics, because as I already told that when the ray is incident over a particular object, the same will be reflected back. That comes under the attributes of optics. Then spectroscopy, the analysis of all the spectrum related aspects. Photography, computer for analysis. Electronics and telecommunication for the transmission and reception purpose. And satellite launching. So these are various attributes of remote sensing systems, or we can say various parts of remote sensing systems, without which it has not been possible for a system to exist. Now, remote sensing components. What are the remote sensing components? As shown in the figure, first of all, there is the energy source or illumination. That is the sun. That is the primary energy source in case of remote sensing. And after that, there is radiation and atmosphere, that is denoted by B. Means the incident ray will incident on C, that is the target. So the incident ray will incident on the target and it will reflect back to the sensor. Here D is the sensor, that is the satellite used as a sensor here. After that, E denotes transmission, reception and processing. Once the sensor got the information about the particular target, then the further evaluation and interpretation goes here. And finally, to the application. Now, remote sensing platforms. It can be ground-based, airplane-based, and satellite-based. Ground-based means you can take the images of any particular area at a particular height on the ground itself. Means in physical connection with the ground. You are taking the images, that is basically come under ground-based. Then airplane-based, or you can say aircraft. In that case, the imagery that is taken at that particular height, that is airplane based. And finally, satellite based. Now in remote sensing, as satellites are used as sensors, so satellite systems collect data in multiple electromagnetic spectrum bands, means in different wavelengths. For example, visible and near to mid-infrared wavelengths. In that case, there are several kind of resolution types in remote sensed images. Spatial, temporal, spectral and radiometric. So spatial means it is the ability of the sensor to identify a small distinguished difference which is visible to the human eye. Means how much detail we can acquire from a particular sensed image. That type of resolution comes under spatial resolution. Second is temporal. Temporal means time based. Means it is the measure of how frequent the data that are obtained from the same particular area. That comes under temporal resolution. As you can see here, this data and this data, they are taken at a different time. Third one is spectral resolution. Spectral resolution describes the ability of the sensor to distinguish and to define wavelength intervals. It comes under spectral resolution. The finer the spectral resolution, the narrower the wavelength range for a particular channel or band. Visible light is shown here. Now, last resolution is radiometric resolution. It is the ability of the sensor to distinguish the brightness of a particular image. As you can see, this one is dark and this one is light, bright in nature. So it basically determines and defines the signal strength of a particular image. So these are various resolution types that has been used in the remote sensed images. Here comes passive versus active sensing. So two kinds of sensing are there. One is passive, another is active. In case of passive sensing, passive is word is used here for the systems which use the resources which are naturally available. Means passive sensors are those which measure energy that is naturally available. For example, sun. Passive sensors can also only be used to detect energy when the naturally occurring energy is available. So you can easily say that passive sensors will work only when there is the availability of sun hours. But in active sensors provide their own energy resource for illumination. So the sensors emit radiation which is forwarded towards the target, and the reflected ray or the reflected radiation is detected and then measured by the sensor. So it will work in day and night because it is independent of the passives, because it is active sensing. It provides its own energy source. Now comes remote sensing imagery, the types. Broadly, there are three types of remote sensing images. Satellite images, as I have discussed prior to that, aerial images, and synthetic aperture radar images. Now, aerial photography. As you can see in the pictures here, you can easily see the buildings and the ground levels because these images are taken at a particular height, or you can say from aircraft or airplane. or at a particular tower elevated on a mountain hill. So aerial photography is basically taking the photograph of the ground from an elevated position. Platforms, as I told, can be aircrafts, helicopters, airplanes, parachutes, etc. Second comes satellite imagery. Satellite imagery refers to the digitally transmitted images taken by the artificial satellites which are revolving around the Earth in their particular orbits. Why this satellite imagery is important? Because the satellites are once placed in their orbit, they are continuously revolving around the Earth, and so that we are getting a repetitive coverage of a particular area. So we can get the same area images at different times. Thereby, we are here for the detection. Advantages of this satellite imagery include large coverage area. As you can see in the pictures also, the satellite is here and it is revolving around the Earth, so it is taking pictures continuously in a repetitive manner. So it covers a large coverage area, thereby providing a very high resolution. And second, easy acquisition of data over inaccessible areas. Easy acquisition means the areas where people can't reach, the images of that particular area are obtained with the help of satellite sensors. Now next is SAR images or SAR images. SAR stands for synthetic aperture radar. These images are also beneficial as compared to the satellite images, but both images have different aspects. SAR images or SAR imagery can used in that particular area where penetration under the ground is required. These images can be acquired day and night because these are independent of the weather conditions. SAR is an active sensor providing land cover data in the day or night. Now, in the diagram, this is the SAR antenna in the satellite. Here is the antenna footprint, means at which the here radar is connected over here, and it is the view angle, and the coverage of radar is shown by yellow line. So this will be the incident angle. This is the altitude. So this is the area of which SAR antenna can capture. SAR images are high resolution images produced by taking the advantage of long-range propagation characteristics of radar signals. As I told earlier, that if we have to detect the changes or the areas inside the Earth's surface or some other object, so the long-range propagation characteristics of radar signals are taken into consideration for that particular purpose. It has various applications. It is used in environmental monitoring, earth resource mapping, and military systems provides terrain information to geologists for mineral exploration. Why satellite images? Why do we use satellite images? Because these images contain multispectral bands, which are used as a good source of data, because large amount of useful information can be extracted from the Earth's surface. And that particular data can be useful in the field of surveying, management of natural resources, and study of environmental factors. Satellite images are beneficial specifically as compared to aerial images because, as I told, it is providing a very high resolution, easy acquisition of data over inaccessible areas, cost effective, and better analysis than aerial photography. Main two advantages are there. First is the large coverage area, and second is the repetitive period of the satellites, so that same images of same path, or you can say particular thing, can be taken at different times. So that is why satellite images are beneficial for the images. Now, satellite images and sensors. Remote sensing is the science of obtaining information without actually being in contact with it. That I told earlier also. Now we come on the various kind of satellite sensors which actually collect the exact picture of a particular area. Multispectral satellite sensors. These sensors record the amount of reflected radiation for each pixel in each band. For better understanding of the information, visual representation of the numerical value is required in case of multispectral satellite sensors. Various examples for these kind of sensors include Landsat, spot satellites, IRS, and QuickBird. Now, enhanced thematic mapper plus bands. And it has provided a spatial resolution of 30 meter. Similarly, the other bands are shown in front of you. Now, instead of the multispectral satellite images, there are three land observation satellite images, which are as follows. That is the Landsat images by USA, spot images by France, and IRS images by India. We will have a small glance over these images. First of all, Landsat missions. It was initially launched by NASA of USA. It was the very first satellite to be launched on 23rd of July 1972. The motive was to monitor Earth's surface, means to detect the changes occurring over the Earth's surface at different times. So it was the very first satellite launched by NASA USA. The satellite carried two sensors, RBB and MSS, that is return beam Beacon and multispectral scanner system. These satellites are placed in a near the polar synchronous orbit. These are the sensors under Landsat missions, that is RBV sensors. It is having 4 band and the spectral range in micrometer is given for each and every band. The next is MSS sensors. It has got 5 bands. The spectrum range in micrometer is given for each and every band, and the various applications that can be carried out with the help of these sensors, the images that is obtained from these. First is band 1. Application is emphasizes sediment laden water. Second one emphasizes cultural details. Third, emphasizes vegetation boundary between land and water and landforms. Fourth, penetrates atmospheric haze best. And fifth, hydrothermal mapping. Then comes TM sensors. These are high resolution scanners. They have 7 spectral bands as shown in the figure. Corresponding spectral band, resolution and respective use. As band 1 is used in ground plants differentiation and coastal zones. For band 2, vegetation. For band 3, plant species differentiation. Band 4, biomass. Band 5, snow or cloud differentiation. 6th, thermal, and band 7 for lithography. These are the various applications based on the images obtained by various kind of bands of these particular sensors. Similarly, ETM plus sensor. This is enhanced version of the previous one, that is the TN sensor. It has high resolution band. ETM plus sensor is having this advantages Now, first one was that we studied is Landsat images or Landsat missions. Second one is spot satellites. The satellite was launched by France, CNES, Centre National d'Études Spatiales. It was launched by this. All satellites are placed in sun-synchronous near-pole orbits at an altitude of 830 km above the Earth. Third one is IRA satellite. It was India's first civil remote sensing satellite and was launched on 17th March 1988. The motive is certainly to detect the changes over Earth's surface. Then comes advanced SAR, Advanced Synthetic Aperture Radar. It was launched in 2002. It is an active sensor providing land cover data in the day or night. Means it is independent of the weather conditions and it is working day and night. ENVSAT, that is Environmental Satellite, is an Earth observing satellite still in orbit. ENVSAT carried 10 radar and optical instruments, out of which ASAR is the one. This European Space Agency satellite, that is ESA satellite, is the largest Earth observation spacecraft ever built, providing information about land cover, oceans and atmosphere. Now we discussed about what is remote sensing and what are the attributes, what is the principle and why we do. Now next is the change detection in satellite images. So basically it is important to understand what is change detection. So change detection is the process of identifying the various changes of a particular object or a place or a phenomena by observing it at different times. Change detection method includes map algebra, direct multi-date classification, and post-classification comparison. Change detection is useful in many cases. Land use analysis, monitoring shift cultivation, assessment of deforestation, disaster monitoring, and many more. So what is change detection? The use of remotely sensed data to map the spatial extent and magnitude of changes on the land surface through time. Means detecting each and every part of the particular area at different times and collecting all those data for further analysis. We can do this analysis over vegetation, urban growth, industrial development, for example, gas wells, mines, buildings, etc. Coastal zone changes and geological effects, that is the climate change effects. Change detection methods are based on supervised and unsupervised classification. Supervised classification based methods, they require complete ground truth for each and every image, and they require classifiers for identification of changes. Supervised methods are even time consuming as compared to unsupervised classification methods. In case of unsupervised change detection methods, no ground truth is required for further analysis. So it is a good idea to move towards unsupervised change detection rather than supervised change detection. You can see an example of change detection. The picture showing a lake in Mississippi, 1993. That is the satellite image of this. And after the flooding, we can see in the picture the blue color has been spread, showing the effect of flood. So this is an example taken of 1993 Mississippi flood, which is detected by the satellite images. So these two images are taken, that is the pre-image and this is the post-image of the flooding. Similarly, another example, this is December 2009 image of the same and March 2010 image. As you can see, the change is clearly detected here. The green one shows vegetation and the blue or channels or rivers shows the water. So this is showing a certain change detection over this particular area. Now, change detection methods. What are the change detection methods we can study for a particular change detection technique? So what are the basic steps for satellite-based change detection? First of all, acquire multi-date imagery. Means obtaining multi-date imagery means there are two things in case of images. One is bitemporal and multitemporal. Bitemporal means the same particular then applying change detection algorithm, characterize change in the form of visual interpretation or transition matrices, and report the results. So how change is detected? It is basically by first we have to take initially the image, and further change detection is done by finding the change using change detection algorithms. After that, applying classification over them to separate changed and unchanged areas. Change detection are characterized based on the Algebraic transformation. So basically different change detection techniques are described over this diagram. that is the block diagram of various change detection algorithms, classified into two: algebra and transformation. In algebra, there is image differencing, image regression, image rationing, vegetation index differencing, and CVA, that is the change vector analysis. Second part is transformation. Under it, PCA and chi-square comes. So these are broadly classification of change detection algorithms that has to apply over the remotely sensed acquired images for proper change detection over them. We will discuss a few techniques in the later part. So question is, why change detection and what is the need for that? As you know, Earth's surface is changing constantly in many ways. There are two things to consider. One is time scales and another is spatial scales. Time scales means which are changing from catastrophic events to geological events. Catastrophic means earthquake, flood, these kind of things. And geological means continental drift. So this comes under time scales. These are very heterogeneous. Second is spatial scales, which are also very heterogeneous, and these vary from local events to global changes. Local events means some construction, suppose road construction. Global change means change of ocean water temperature. So these are the changes that occurring continuously over the Earth's surface. So it becomes very important to detect those particular changes. Therefore, change detection is a challenging task, and of course it's very important. Now, first detection technique is image differencing. In this technique, basically, bitemporal satellite images are subtracted pixel-wise to obtain a difference image representing the change. And it is done by using absolute differencing algorithm. As you can see, IAD equal to IT1 minus IT2, and K is taken as 1 to M. K is the band, kth band we have taken. T1 and T2 stands for the images taken at time 1 and time 2. So this is basically a very simple method of image differencing, just taking the image photography of a particular thing at two different times and just make a difference of it to calculate the change. But an important consideration for this technique is to decide that the threshold boundaries between change and no change pixels should be placed in the histogram. Second is image rationing. It is a comparatively fast method for detecting the changed areas. In this method, spatially registered bitemporal images are taken, and these are ratio evaluation is done over these two images. When the ratio is 1, it represents no change, but when the ratio is 1, more than 1 or less than 1, then it reflects some changes. It reflects the changed areas. So the critical point of this method is the selection of suitable threshold values in the lower and upper tails of the distribution to identify the changed pixel values. Then image regression. In this method, one image is assumed to be a linear function of the second image, and the first image is adjusted to match the radiometric conditions of the second image, that is the reference image. Describing two outputs, change magnitude and change direction, by processing spectral as well as temporal information of the image. The vector containing the direction as well as the magnitude of change is called spectral change vector. So this technique basically analyzes the multiple image bands to detect the change. Pixel values are considered to be the vectors of spectral values, and change vector can be computed by subtracting vectors for all pixels at different times. There is a drawback in using this technique. The drawback is that it requires the acquisition of remotely sensed data from same phonological period, and furthermore, the land cover change trajectories are difficult to identify. So this is one drawback in CVA technique. But the advantage of the technique is that the reflectance properties of various bands of the image can be combined so that becomes capable of analyzing change concurrently in all data layers. Because the properties are combined, so it is capable of analyzing change concurrently in all the possible data layers. Next technique is PCA, that is principal component analysis. It is a statistical procedure for data compression. The first principal component usually accounts for most of the variability in the data. It allows you to pick out patterns and relationships in the variables. It isolates and defines features more thoroughly than conventional band combinations. Basically, it is a multivariate technique. It reduces the spectral components into a less number of principal components. Means the component which is having high and largest variance, so it will reduce the number of spectral components into less number of principal components. Covariance or correlation matrix is used to transfer the data to an uncorrelated set. Sort the resulting matrices consisting of eigenvectors in descending order. Most of the data variation is expressed by the first principal component. The next largest amount of variation is defined by the succeeding principal component and thus is orthogonal or independent to the principal component that precedes it. There are two approaches, separate rotation and merged rotation. Next one is vegetation index differencing. In this method, ratios called as vegetation indexes, are computed to enhance the spectral differences based on strong absorption and reflection of electromagnetic spectrum. These indices, that is ratio vegetation index and normalized vegetation index. The advantage of vegetation index differencing is emphasizing the spectral response of different features and reduction of impacts of topographic effects and illumination. This method provides very accurate quantitative results for delineating forest canopy change, but it was less accurate for delineating forest clear cuts. Then post-classification comparison. In this method, classify each image from different dates, means taking the training area set, classify the images and compare the classifications. In this method, each image is rectified and classified separately. Both supervised and unsupervised classification techniques can be utilized in this method. It provides the complete matrices of change, reducing the impact of atmospheric, sensor and environmental effects. The limitation is that the accuracy of the final image, it depends on classification accuracy. The disadvantage is that it is a little time consuming and difficult task. This is an example of a pan-tropical area transition matrix for the period 1980 to 1990. Showing the land cover classes in million hectare and land cover classes 1980. The same thing is written over here and showing the changes over these columns. Image fusion is a term that is applied before the change detection map is obtained. So these are the image fusion techniques. In this case, image fusion aims at combining complementary and redundant information from the numerous images of the same place to produce a fused image. It is used to combine panchromatic images having high resolution with multispectral images having low resolution. It is basically means you are taking several images of a particular area by different sensors. This method is multi-sensor fusion. That is the simply combination of various kind of images. So input images are first pre-processed for extracting the information and then fused according to the fusion algorithm. First point is no salient feature contained in the original images should be discarded by the fusion method. Second, it should not lead to any artifacts which can disturb in image processing. And third, it should be reliable and tolerant to noise and misregistration. So the images showing here, as in we are taking it as an example for change detection, for showing the change detection. So these two images are the geographical area of Alaska, acquired on 22nd July 1985. It is the first image, it is a satellite image acquired on 22nd, 1985, and second image is acquired on July 13, 2005. So these two data sets are taken for showing the change detection. These two images are acquired by Landsat 5TM satellites containing 7 bands. Now, in that particular image differencing algorithm has been applied and difference image has created. Then another change detection technique, CVA, that is change vector analysis, is done over the image. Secondly, fused image has been obtained. And finally, the change map. So as you know, change detection becomes important as far as various attributes of obtaining the information is concerned. So certainly it is having applications. Certain applications are evaluate deforestation, study the urban growth, study the impact of natural disaster like tsunami, earthquakes, flood area detection, detection of structures made by man like buildings, as we can see in the aerial photography, monitor shifting cultivation, study the changes in vegetation, land use or land cover changes, seasonal changes in crop production, damage assessment, burned areas identification, crop stress detection, and snow melt measurements and other changes occurring in the environment. So this is a various classification of all the things that has occurred over the Earth's surface. So it certainly is a very important topic, and it's a very innovative research area even in the image processing, that is the change detection over Earth's surface. So change detection is very useful application of remote sensing. We have studied various methods, various change detection methods. Some have strengths, some are good, some are not that much up to mark. But choice of a particular method depends on the application. Depends on a particular application. So the future of remote sensing is, as you all know, technology is growing day by day. And in this field, in remote sensing field, new platforms and better observations make it amenable to use for society benefits. Remote sensing tools will be highly useful for not only making decisions at grassroots level, but also understanding the global change issues. These are the references. Thank you. Any questions?
I heard that mission named NISAR, on which both NASA and ISRO are working together. How will it be worked?
Sorry, can you please repeat the question?
I heard that a mission named NISAR, on which both NASA and ISRO are working together. How will it be worked?
I don't have such kind of information right now, but I will definitely revert back to you soon.
Where can we download multispectral 4-band high spatial resolution, 6 inch or so, preferably urban land cover for free.
For free. Please repeat the question again.
Where can we download multispectral 4-band high spatial resolution 6-inch or so, preferably urban land cover for free?
It can be taken from the satellites that are revolving, the artificial satellites that are revolving around the Earth. And as India has IRS, as I mentioned, that is IRS satellite. It was launched on 2002, so we can easily take data over that satellite.
How can we get training data for supervised classification method?
We have to borrow data from, when I did research in that, I borrowed data from NASA, the actual spectral images. For supervised, you can't take any data from internet that is available. For supervised, you have to take the ground truth data, that is the, you can take it from NASA.
Now, one of the participants is asking, can we get this PowerPoint?
Yeah.
You can send it to me. I will send it to that person.
Okay, sure.
Thank you very much, ma'am. Then see, just one more question.
Yeah.
Is there any other source like ULCF?
Hmm. Hello.
Yeah, ma'am. That's any other source like ULCF.
Hmm. As in for the change detection purpose.
I hope they can clarify.
No. Any other method, you will see if that's it. The question is, that's it.
Yes, ma'am.
I mean, but what about the question? I mean, that's not a complete question, I think. In
Yeah,
what
I
sense,
hope they
in
can.
what, in what sense is the person asking? In case of change detection or in sensing principles?
Could it be used for 3D structure designing?
For 3D structure designing?
Yes, ma'am.
Yes, in my opinion, it can be used. Because right now the process of and the field of remote sensing has been continuously being researched, and it has developed a lot, even more than if we compare with the last 10 years. It has been enhanced so much, and various research industries, they are doing very good in that, so definitely it can be used.
If sun is primary, then how can we obtain image in night?
No, I have uh, taught about active and passive sensing. So in active, sun is the primary source. That is the passive sensing. In passive sensing, sun is there. So we can acquire the images only in presence of that. But in active sensing, the sensor from itself, it provides the illumination source. So in active, the sensor provides the source, and active is used wherever passive is not present, means sun is not, means where there is night. Okay.
So the other person has clarified that any other source like glcf.umd.edu for land cover repository.
Hmm.
Thank you very much, ma'am. That seems to be all the questions. Thank you for the presentation.
Thank you so much. So is that done?
Yes, ma'am, I will close.
So I can close.